All right, so we're going to use this compound interest formula here. It says the formula A is equal to P times 1 plus R over N, all raised to the N times T, describes the accumulated value A of a sum of money, P, the principal, after T years at annual percentage rate R in decimal form, compounded N times a year. It says complete the table for a savings account subject to N compounding periods per year. Okay, so this question is asking us, well, if you invested $14,000, okay, um, number of compounding periods, it will be two means semi-annually. So you've deposited a certain amount of money every 2 months. Okay. Um, this is how much you invested. This is how much you accumulated at the end at this particular interest rate, 6.75. Now, one thing I want to say, and I always said, anytime that we're dealing with a word problem and it has percent, you want to make sure you convert that to a decimal. So this is going to be 0.0675. The question is asking us, how long did it take us to invest this money? Okay, this is what we want to find. Time T in years. Okay, so what is given? We are given A, the accumulated value, excuse me, wrong one, the accumulated amount, the principal, what did you deposit or what monies did you invest, and then N represents our number of compounding years, and then R represents the annual interest rate. We want to find T. All right, so in doing so, we're going to use this formula here. We're going to plug everything into this formula. So we have 24,000 equals to 14,000 times 1 plus 0.0675 over 2, all raised to the 2 times t, because we don't know what t is. That's what we want to find. So now our goal is to get t by itself, and t is in the is written as an exponent. So this is where we're going to have to use um, natural logarithmic form to solve this equation. So follow my lead here. So let's go ahead and take what's inside the bracket. Let's simplify that. So we have here 24,000 equals to 14,000. Let's divide 0.0675 by 2, and that would give us 0.03375 raised to the 2 times t. Add what's inside the brackets. So that would give us 1.03375 raised to the 2t power. So what we want to do, we want to get this exponential component, the 1.03375 all raised to the 2t power, 2 times t. We want that to be by itself. So what we're going to do is divide both sides of the equation by 14,000. Then 24,000 over 14,000 reduced to 12 over 7. All right, so now to find t, we need to bring this t from the exponent as an exponent down to or next to our 1.03375. So what we're going to use is the power rule, but before we use the power rule, we want to take the natural log to both sides. So we have ln of 12 over 7 equals to ln of 1.03375 raised to the 2t power. Now we're going to use the power rule. So the left-hand side, we have ln of 12 over 7. We'll find a value for that, equals to ln of, excuse me, not ln, but 2t times ln of 1.03375. Now, to solve for t, this is what we're going to do. We're going to divide ln to both sides, ln of 1.03375. And I'm going to show you how to put this in your calculator. Okay, so now we have 2t equals 2. Now let's put this information here into the calculator. So I'm going to bring up the graphing calculator. Okay. And let's clear. So first of all, we're going to do this in two parts. So watch me do this. I'm going to type in ln. Let's find that ln. And then we're going to say 12 divided by 7. Close it with a parenthesis. And let's press enter. So we see what the numerator is here of ln of 12 over 7. And then we're going to divide this by ln of 1.0337. So let's enter divide. And then let's type L or click on ln and let's type in 1.03375. I'm going to close it, press enter. So this is the value that we get, 16.23827.406. In these type of questions, do not round as you're working the question out. You will round at the end. Do all of your rounding at the end. So if you have a long digit to write, write it out. Write it quickly. Now to find t, we're going to divide 2 to both sides. And we have t is equal to, and let's go ahead and use our graphing calculator here. We're going to say divide by 2, press enter. And we have here 8.119137029. And we're going to round our answer to the nearest tenth, meaning one decimal place to the right. So let's look at this 1, and then which I'm underlining, and then we look to the right. If it's greater than 5, we add to the 1. If it's less than 5, we keep the 1. So how many years did it take for you to invest $14,000 twice a year? This is how much you invested within the 8.1 years. Okay, it took 8 years for this investment to happen for you to accumulate $24,000. There we go.